That's fine. I mean, I'm gonna do it on there. Good. Yeah.
So it's like that, right? But like it's like it'll be the same.
Exactly. Due to symmetry. Yes. Just do the positive, or just do the negative and make it positive. Either one. So okay, so it looks like most of us are just finishing this up. Okay, so where does the 99% go? The middle, very good. We're looking at the number of standard deviations away from the middle. That includes the 99% of the data. And we're going to find that. So if we have 99% in the middle, what's our alpha? Do you guys remember? Good, so alpha is 1% because if we have 99% in the middle, we have 1% left over on the sides. And so that means how much do we have on each side? Good, 0.05. So either 0.05%. Wait a second. Yeah. Let's just use, area. 0.005 here and 0.005 here. Because 1% is 0.01. So if we divide 0.01 by 2, we get 0.005 on both sides. How do we find the z-value? Good. Norm.s.inverse. Norm.s.inv. What am I going to put in here? Which one? 0.005. That's the first option. What's the second option? Good. You either put in the left one, which is the 0.005. Is the right one also 0.005?
No.
Good. It's 0.995. So if you have 0.005 on this side, you have 0.995 on the other side. So you have to make sure that you put 0.995 here. And after you do both of those, I have to go into Excel because I do not have these memorized. Oh, actually, I do have this one memorized. This is a pretty famous one. This one's negative 2.58, and this one's positive 2.58. Did anyone get different answers? It's possible I memorized the wrong one, but I've done this one so many times. I have the numbers. So which one do we really want to use? Do we really want to use the negative one? No, we want to use the positive one. Now we're going to make a confidence interval, 99% confidence interval. So we don't want to do that. So what this means is that 99% of the data falls within how many standard deviations of mean? 2.58. Very good. Just like within 3 standard deviations is 99.7%, within 2.58 standard deviations is 99%. Let's go ahead and use that information to construct our margin of error, just like we did in the previous questions, and then we'll make a confidence interval. So again, this will be a think, pair, share activity, making the confidence interval. And that's the last problem of this page before we take our quiz.
Heavily call 309. Whatever.
We are using the original, oh, that's a great question. We're using the data at the top here, very top here, this one. Oh, I did not mean to do that. It's 14. Okay, you're right. We need a lot of information here. First, we need the mean. We have random sample of 36 bottles, and that's $14. Then that'll help us get started. And then what else do we need besides that? Standard deviation. So I actually gave the standard deviation. So it's good. Standard deviation's over here. Standard deviation's over here. Hold on. Don't use that mean. Don't use this mean. We don't know this one.
Standard deviation.
Standard deviation, we're pretending we know the standard deviation. But we need the 14 at the top with the 36. Maybe there's a way for me to get both of these on one page. I think there is. I'll just keep like alternating between pages. Okay, I'm coming around to check to make sure we're doing this. Don't forget that standard deviation.
That's going to be
We're doing right now.
We're going to do it after this problem. So basically the quiz is like pretty much the same problem, but a different problem that's just like this. So if you can do this one, you can do the quiz. Don't forget to divide the 21 by the square root of 36.
And the other question. It's just
Great class, man. Cool sounds and all.
Yeah, I'm just waiting on it to be bigger to come.
Remember that, see, that's why I wish you guys had your notes from last class, because we're basically doing the same thing, we're just changing it to 2.58. The last one was just
It's okay, it's fine.
Don't forget that the 21 has to be divided by the square root of 36.
So, 36 is the balls, right? It was like this.
Okay.
Yeah, so right. 2.58 is the yeah, and then 3.5 is the 3.5 is like the 21.5.
Please try to do this without me going over it, because I'm not going to go over it during the quiz. I'll answer questions, but I'm not going to.
Wait, you do
3.5.
21 over the square root of 35.
Yeah. So what's the deviation?
Although I think everyone's good. Everyone's
Oh, so. It's not, it's 21, that's Oh, so.
Nine
I think
thirty.
we still have like one or two.
I think you guys should be the teachers.
Oh, yeah, actually, that's what I was thinking too, but then I was like,
That's fine.
Okay, let's go over this. Let's look at a previous problem. Let's look at what we did for the 99.7% confidence. Remember that our X bar was 14? Let me change this color to like something that's like way more better. This was 14. How did we find the margin of error for 99.7%? What's the empirical rule on 99.7%? It's 3. So we took 3 and we multiplied that by the standard error, and that's 21 divided by the square root of the sample size, which is 36. That's 3 times 3.5, which was 10.5. And then we did 14 minus 10.5, and then we did 14 plus 10.5. Do you guys remember doing this last class? Okay, good. I want everyone to look at this. Everyone, we're reviewing. I want us to get 100% on the quiz today. How about if everyone gets a 100% on the quiz today, we'll get an extra credit point on the next quiz.
Well, I think we already have an extra credit.
That's
Yeah, we
true.
have 2 from last week. So
Okay.
let's round up.
We have 1 from last week. We
oh,
had
Oh, no,
1
no, no,
from
no.
last
It was
week.
like 1.75. I remember.
Okay, how about, okay, 1 extra credit point on today's quiz. If we all get a 100, we'll just bump our score up to 15 out of 10 for today.
Yeah, that's fair, that's fair.
Okay,
okay.
so then here we get 3.5 and 14.5. But we all have to be on really good behavior today. I want us to all be taking in some great information so that we can all get that 15 out of 10 on the quiz today. So here we have the 3.5 and the mean between 3.5 and 14.5. What's the only thing that changes for 99% confidence? Well, the standard deviation is still 21 divided by the square root of 36. Where did the what did the 99.7% become? It became the 3. So what does the 99% become? 2.58. So now this becomes 2.58. This is still 14, and then we have to do this calculation. So this part's not so easy. So I'm going to do it in Excel. So I have 2.58 multiplied by 21 divided by SQRT of 36. And I didn't put my extra, oh, it says 9.03. So this is 9.03. And then I'm going to do 14 minus 9.03. And then I'm going to do 14 plus 9.03. So equals 14 minus 9.03 is 4.97. And then here we have 23.03. How many of us got the exact same answers? Okay, good. Very good. I think we can all get this 15 out of 10 on the quiz tonight. Oh, wait. We have to make sure that we put, what is it, 99% chance. Was the actual mean in this interval? Question, was the actual mean in this interval? What was the actual mean?
15.
15. The sample mean was 14. We don't know what the true mean is, but we just know that there's a 99% chance between these two values. The actual mean was 15. It is in between. Good. Yes?
This is a question going like way back. So you know how we're using 14 for the means of all these?
Yes.
But we got the 21 from where it's questions 5 to 19 for finding the standard deviation of X bar.
Yes.
Why are we using the 21 over square root of n and using 14 instead of using 15 when we were given that
So
earlier?
really, we should be using both the sample mean, which is 14, and the sample standard deviation. So this is the problem with doing confidence intervals like this. It's sort of what we call a pretend confidence interval. And then in the next section, we do the real confidence interval and we use the sample standard deviation.
Okay, so in the real one that we're gonna go up to, they'll give us like the standard deviation and the sample mean in the same column instead of giving us the
Exactly.
smallest one? Okay.
Well, the 21 is the true standard deviation, but how do we know that? Because we don't know the true mean either. So if we don't know the true standard deviation, we don't know the true mean. That's why we're making the whole interval in the first place. This is actually a really good question. I designed the lesson so that we would have this question. Because in the past, I would just do the problem, and everyone would do the problems, and we know how to do the problems, and then we wouldn't really think about it like you were thinking about it here. And that will help us remember why we're supposed to do the problem this way, because we don't have that information, et cetera. Okay, excellent question. Does anyone else have a question? Give me anything. It doesn't have to be as advanced as Nicole's question.
When will we use the real mean and the real standard deviation, or will we ever have to?
Okay, we're never going to use the real mean in the confidence interval because we're trying to estimate what the real mean is. We may have the interval, and then later they may give you the real mean, which is 15, and then they say, is it inside? And then we say, yes, it is inside.
When we do this, you'll always be using the sample.
You'll always be using the sample rate, and we should be using the sample standard deviation too.
Okay.
But we haven't adjusted the confidence interval yet to do that. That's a good question. Any other questions? These are really good questions. I don't know if my lessons have gotten better or if the Chapman students have gotten smarter. I guess we could just say you guys have gotten smarter.
No.
Okay, so, I mean, the Chapman entrance, requirements have been going up, so there is constant. Okay, so for the quiz today, it's open notes, open everything, open Excel. You can either use the computers in the back or you can use your own computer. It's also open professor. It is not open student, so you cannot use another student to help you. In fact, I want everyone to sit away from everyone else, so that way you're not having extra help from your partner. So as soon as you're in an isolated area with just appropriate Excel activities out, I will give you the quiz. Well, actually, that's fine. Where you guys are. Oh, and I just realized that I'm gonna have to explain this. I forgot to explain part 2 of the quiz. I'll do part 1. Is it possible, just because I know Hannah's over there, so you guys do this a little bit?
She's sneaky.
I didn't say that. Okay, so. Here we go. Did you get the consent data? I'll explain. Just do the first problem. The bottom says mid-semester survey. I'm going to talk about that as soon as I hand it over. And then you guys are pretty nice. Thank you. Okay, so just do the problem. Don't worry about the mid-semester survey. Just do that. When you finish the problem, if you want to do the mid-semester survey, just raise your hand. I'll give you instructions on how to do that. I'm already giving 5 extra credit points. Oh yeah, it's on the back. Here it is. So the one that goes here is it's like marble so always. Exactly, because we want this standard deviation, I don't want that. Oh, original population right here.
Oh, okay.
Have the answer pieces. I can only answer as much as I can say that's the correct answer. Well, how did you get the number?
Oh, just kidding, just kidding. Wait.
You have to you got the 2.58.
Yeah, but oh, just kidding.
It does. You have to plug the 2.58 times the 3.5
To get this.
to get.
Is that this time? Because we don't use that again.
This whole thing is not. I should get.
Oh, not there, I went wrong. Yeah.
So then to answer your question, you do have to.
So yes, okay.
If you found the margin of error and that helped you find the confidence interval, that's fine. So you basically have to find it to find the interval. So you don't have to label it separately. Yes, we need to make sure that we interpret the answer. So yes, Erica, to answer your question, we have to make sure that we have to interpret the answer. That was an excellent question. With the this whole thing, so make sure they do the interpretation as well. Yes. Yes, but the most important thing is the whole answer, which is to make sure that you get interpretation. Yes. Exactly. I'm sure that that's what we've done. 0.03. Yes.
So did you this survey? Did you know this? Or what you could do is you could write your answers on here and do it on. Things I do want them. I want to make sure that maybe about 5 minutes. We'll start the next one. You know, so what I recommend yeah, if you want to quickly go over this. You should. I mean, ultimately, I want to make sure that I see that the 97. The person that's looking at the report. I mean, at this point, I feel like you got it. It's just a matter of cleaning it up. On Microsoft Word. Yeah. I'm hoping it's prints because I can't have you guys email it. And I really know it's done. Yeah, but oh, I mean, I like to see this just with the but I mean, I wouldn't change it at this point. It's basically just for the next. Oh wait, multiply by this. So anonymously, I don't think the answer. Just write 1, 2, 3. There's no need to restate the whole question. For this survey, please do not type up what the problem says. Just write 1, 2, 3, and then your answer for 1, 2. Although that 1 is what you like about the class, 2 is what you want to change, and 3 is self-answer. Yeah, hopefully it's working. If it's not working, I'll throw For instance, I don't know, like, that it's yeah, please do your best on these typing problems. Just go straight. Yeah, but it's actually better to write, to do this at the top and then final answer.
test though. On the test, I want to see it a little cleaner. For now, it's fine.
Let's get this. This stuff.
No, it's, if you get it on Excel, it's like pretty legit here. Also, you may need the computers for question 1 of the next lesson. So if you are done with the survey, then bring your notes from question 1. Okay, I'm gonna come over here without trying to look at anything. So, I'll try to like stand over here so that you can try to help. What happened? I didn't really that far. I'm on these stand first. Okay. What printers are on there?
The LLB 16.
The LLB 16, I think is the one that is supposed to work.
No, I tried to
Yeah.
save her. Maybe it's not all. Is it buttons on it?
Let's see what it does.
Green light.
There's a line on it, not really. It worked for me last time. Yeah, who's really good like printers and wants to like build a printer?
No, I'm not.
You're like sitting right there.
Alright.
You guys are really pushing for the extra credit. Yeah. Don't make me take those 5 extra credit points away. That was. Yes, on the task, just this part. The other part's work, you don't want to put that in front. No. We're all doing this work. Okay, how about just take a picture of your screen with your cell phone and we'll figure out what to do later. So take a picture or what? I don't even remember if you said it. Well, I just want you guys to be like as honest about this as possible.
It says stop it. Which can't be good.
If we don't care for you, like to email us? Well, I,
You don't care.
I don't care.
Okay, if you don't care, just go ahead and email us, that's fine. But if you do want it to be anonymous, take a picture of it, and then I'm gonna figure out, print it. when you're done with the survey, turn in your quizzes, because I am. Okay, so far, everyone's turned in the same answers. Let's take one more minute for the survey. Just take a picture of it with your phone or your phone. It's not pretty anymore. I just want you to double check this. Good. So far, all the people that have turned it in have all gotten the same answers. That's good for 15 extra credit points. I just want you to
I know you
double check
can.
that.
I know you can't tell me the answer, you tell me let's double check.
I can't, because there's so much extra on that thing. But I can't give it back to you, look over it, so. Are you sure this is left to go? I think it's a 1-2. Wait.
Oh, survey. Yes.
If you feel comfortable, email me. Open, others can start. So if you, oh, the printer's going, okay. Now it's gonna print all of them. So we didn't need to do that. Well, did you click print on there? Okay, go ahead and take a picture of it and then print it out when you get home and then you'll turn it in next time. Okay, so did everyone turn in their quizzes?
No.
Okay, I know there's a lot at stake here for the quizzes with the 5 extra credit points. I'm gonna take the quiz. This is also good. Who has not turned the quiz in yet? Did you turn it in yet? Yeah. Okay, good. So far, everyone that's turned in the quiz has the same correct answer. Okay, that's all. Okay, again, everyone, I believe has the same correct answer. Again, I can't guarantee anything because I've only gone through all the numbers, but it looks like we all have the same answers so far.
You really went back.
At this point, we have to. Well, I think there's more than one, so it's not just you. Nicole, I'm afraid you have to turn it in. I can't let you go forever. Okay, we are starting the next lesson.
Yeah.
Okay, let's all come back to the main section. Let's get our partners ready. Okay, now we're going to learn how to deal with the fact that you don't have the standard deviation. One of the things we need to do is review our symbols. And it's okay if you're not still at Excel, but you will need Excel to do some of these calculations here. We're going to review what all these symbols mean. So what I want us to do is draw a line from the population mean to what the symbol is. If it's that, if we believe this is the population mean symbol, draw a mean to that. And if you can calculate the population mean from the given sample data, draw a line from the population mean to whatever value it is. So do you want to use Excel or calculator to do the calculations?
That's right, so far so good. Okay, none of this is actually the survey. You wanna see what it printed? It did not print any of your surveys, it printed like completely.
I printed mine,
It did?
but I took it, yeah,
You took it, okay.
just in case.
So weird that it printed all of this. Okay, groups of two, think pair share, matching. Okay, come
For the single name was 14.
on. Good.
The
Did you guys have an Excel option?
it was a 36.
No, that was the simple size. 36.
Oh, this is a completely different program. This is
Okay, you're gonna create somebody unfortunate.
the name should be 14.
Maybe I'll let them after class.
And then I assume because college ones are more specific than this year.
Okay, so we're all matching, do the calculations, use Excel, I don't recommend doing it by hand.
Can you put all this into Excel? Is that what we're supposed to do?
Yes. Plug all the data into Excel. Come in the call. So David, if you want to, David, if you want to look at it after class, you can. Okay, we're doing lots of calculations. Yes, all data into Excel. Yes. So not all the values in the last column are exactly. Oh, you forgot to turn the present. Okay.
So now, understand. Is this a function?
Is this the same?
It's the same 36.
The same standard deviation of six going to this.
Oh, the average.
We should change the immediate to less.
We had this 21, 99 nowhere. So, just pretend it's not.
And then do.
Makes it easier. Sample size, and that one should be.
Oh, right, yeah.
Also figures. Good, X bar is definitely 14,
That's
very
14,
good.
8, 9, so that's the one that was sample, or
Sample standard deviation.
samples, or, yeah, sample standard deviation is 14.5.
Okay, so make sure to put the sample standard deviation to the symbol first and then match the symbol to the.
Oh, sorry.
Are you sure that sigma is sample standard deviation? Population standard deviation is sigma.
I'm just gonna draw one.
Sigma X.
That's the standard deviation of the sampling distribution.
That's far. Yeah, and then population mean is that. Isn't that population? And then N is the sample size. And sigma is the.
Okay, I'm gonna just go over this because I think we're like right there. Oh, well, you know what? I didn't put all the values into Excel, but what I can do is, oh no, I can't do that. I think I can, oh, I don't want to do that either. Okay, you guys can spend just a little bit more time on this. I'm going to see if I can copy and paste the values into Excel. Oh no, that's not what I wanted. Okay, we're gonna officially go over this now. We have to remember our symbols. Now, a lot of people get these confused, so I'm gonna give the answer. What's the symbol for population mean? U. So we just put this straight across. What's the symbol for population standard deviation? Sigma. That's this one. Okay, sample mean. What's the symbol for sample mean? X bar. Sample size? N. Sample standard deviation? S. Okay, so this is where some students get confused. Oh, I thought sample standard deviation was this. Is that sample standard deviation? What was this again? Is this the sample standard deviation? What did this come from? Good. That's the population standard deviation divided by the square root of the sample size. That's also the this is also the standard deviation of the blank distribution. You guys remember that weird word? So this is the population standard deviation divided by the square root of n. It's the standard deviation of the sampling distribution. Remember that whole lesson we did on sampling, where we saw that all the standard deviations got smaller? You really don't remember that one? Okay, let's quickly look at that lesson. That was, I think it was 7.3. It's this one here. Remember we looked at the Disneyland tickets and then we looked at all the possible samples. These are called sampling distributions. Sampling distribution is a little bit familiar. Okay, so standard deviation of X bar is the standard deviation of this, of these things. It's not the standard deviation of the sample, it's the standard deviation of all the sample means. I want us to maybe write this out because we get this confused. Okay, I want everyone in groups of 2 to write what the difference between this is and what this is. Okay, groups of 2 think, pair, share. What's the difference between S and sigma of X bar?
Wait, is sigma
Of all the means. Yes.
That's just a different thing for it. They're like not the same thing. It's not like sigma.
It's like.
Oh, sigma.
Error, standard deviation of what the sample means.
Oh, okay, so
That's why it has a little
that's
X
the
bar
population.
next to it.
Wait, why is it called a sampling distribution if it's a population? Why is it called a sampling distribution? Yeah. Population.
Because a sampling distribution is a population. It has
Oh,
every.
it's just a different word for it.
Exactly. It's
Okay.
all the samples possible.
And then this one is the actual sample.
Exactly. Hey, what did you guys say? Okay, these are not the same thing. No, because that comes from a sample, that comes from the population. Okay, one extra credit point to the group that wants to share their answers between these two symbols. Okay, let's start with, I saw your hand go up first, Selena. What's the difference?
The S variable is the sample standard deviation, and the sigma X is the sample distribution, which is actually population.
I need a little bit more than that. Okay, I think I saw Michaela's hand up. Second, good. You said everything that was true, but I just need a little bit more.
Okay, so S is standard deviation and sigma X bar is the standard deviation of the sample.
Okay, good. That's still the exact same thing that Alina said. Both excellent answers, but I'm looking for a little bit more. Yes.
So S is the sampling, yeah.
Don't say sampling for S. S is sample.
Sorry, that's what I meant. Sample of the thing. Sorry, I totally just forgot what I was saying.
This-
Sorry.
okay.
Sample of the standard deviation, and then the sigma X bar is the standard deviation of all the means.
Good.
Yes.
All the wait, what kind of means? Okay, Nicole?
I was gonna say, S is the sample standard deviation, and then the, the sigma is the population standard deviation, which is the sample standard deviation of the square root of the sample.
Not quite. Okay, here's the full answer.
Extra credit for everyone.
Okay, well, maybe. Okay. This is the standard deviation of one sample. It turns out to be that sample, not this one, sorry, the one on the new paper, the 36 bottles of wine. S comes from just the one sample. Okay, this one here comes from the sampling distribution, which is all the sample means, taking the standard deviation of all the sample means. That's the difference. So you guys had all very good answers. So if we maybe put them together, that might total one extra credit point. How many people volunteered? I think we had 4, so you'll each get 0.25 extra credit on the answer. Okay. Good. Okay, what was the difference again? Anybody want another 0.25 extra credit?
We would love one.
Okay, you already got extra credit.
But
Okay.
it's just.
Okay, somebody that didn't raise their hand the first time, what's the difference between the two? No one was listening? Okay, yes, Andre?
S is of one sample, and then the sigma X bar is multiple, is the mean of the sample distribution.
But it's a standard deviation of all the sample means.
Yes,
Good,
so it's more than one. And S.
exactly. That's why here you see all the sample means here. You're writing a ton of different sample means and you're taking, remember we did stdev.p. Remember doing stdev.p? What do you want to use for this one? stdev.s. So that's how you find the standard deviation. Okay, I'm gonna finish this one. Very good answers. I'm gonna finish this up. So if we look in Excel, what is 14? That was the mean of all these values. So if I do average and then I highlight all these values, it gives me 14. So what is that? Is that sample mean? So I want to draw the sample mean to the 14. Do I know what the population mean is? Why do I not know the population mean? I don't have the population, I just have the sample. Okay, next one. 36 is the sample size, because if I count all 36 of them, I get 36 So n is going to be 36. And now the standard deviation, it's STDEV dot, y is at S. So sample, highlight all the values. What do we get? 14.888. So that one is this one here. Does that mean sigma is 14.68?
Or that could be population. We just don't know.
Okay. Do I have the population? No. So can I figure out what mean and sigma are? No. So do not draw any lines to 14.68 because we don't know what the population is. So we cannot draw any lines to 14.68. Okay, any questions on what we just did? This is an important time. Yes. Okay, so the 14.89 was found by doing stdev.s. If you would have done stdev.p, you would have done 14.68, but you don't want to do stdev.p because this is not a population.
What would you put into the ST? As, like, did you have number enough for that? I'm so.
Oh yeah, maybe I didn't show it properly on here. I did equals stdev.s, and then I just highlighted all my data. And then when I did that, it gave me the 14.89. Yeah, we don't have the population, so I can't do stdev.p. I can't do average of the population. I don't know those values. Yes? If they gave you an entire population, populations are usually super big, and they usually consist of like thousands of thousands of thousands. Most of the time, you're not going to do stdev.p. There were some small ones on the first test because we were just practicing the small samples, but in reality, we very, very rarely do stdev.p. Good question. Any other questions? Okay, so I want to make a confidence interval. Can we make the confidence interval? If we think we can make a 99% confidence interval, circle A and then start calculating it. If we don't think we can make the confidence interval, circle B and then circle what's missing from the confidence interval formula. Okay, again, think, pair, share. We're going to do this individually first, then share in a group, and then share as a class. Start filling it in because even if we end up selecting B, we'll at least have a head start on the confidence interval. So start filling it in. So do we have a
This is the same one. Wait, we have them. This all standard deviation is the difference, right?
Yeah, that's the same deviation.
Wait, you have to have the real one? It doesn't have a population.
Yeah, but like, because like you're taking that from like here as if this is the population, you know what I'm saying? Yeah, but this is.
So it's no. Yeah. Wait, but why, if it weren't no, why would you have a bunch of codes? Because
we're not this.
X bar is still 14, right?
Yeah, export's still 14. Yeah. That's 14. So.
And then you have this, we have the sample things, and then we have, why don't we just use? Yeah.
Huh?
I feel like if I do it, I'm gonna go call them.
What's X bar?
Oh my, yeah, X bar is 14, but don't we need the population to do?
Yeah, so that's so you don't have to
Time,
start.
what was
typing.
the number for that? We can do it, right? Do we have the?
There, we have one thing that's missing.
Why is that missing though? Like what, I'm confused, like.
Because that's the population standard deviation, and we don't have a line drawn to the population. There's no, that's not the
Oh, there are
population.
only 4 choices here. Oh, I
Not-
didn't see that.
Not all values will be used, so there's nothing to be drawn to 14.68.
Wait, what? Wait, then what is 14.3?
It's a fake answer,
But I got,
because if you do stdev.p of this data, it gives you 14.68, but it's not a population, it's a sample.
okay.
So it's like, say like this was actually the population, right?
Yeah.
Then that would be the population standard deviation. But like this is a population, so when you take the data, it's just like, it thinks it's population.
Okay, I think we should start answering this.
Okay.
Let's do a yay or
Yeah,
nay.
I know.
How many think yay, we can do the confidence interval? Well, using techniques we learned. How many of us can think we can do it with techniques we learned? Not, or techniques we have not learned
How would
yet.
we find?
Oh, power.
Okay, I'll just give the answer. It's nay. Why is it nay? Okay, good. You can start filling in the values. You can be like, oh, X bar is 14. And for 99% confidence, what was the 2.58? And then this would be, this is supposed to be sigma divided by the square root of n. Do we have sigma? No, so that's why it's B. We don't have sigma, that's the problem. We can't figure out the confidence interval. I mean, yeah, you could write 99% chance there, that's fine. We're gonna figure out what to do. There's a workaround. And I saw some students doing the workaround. So, Lauren, you were doing the workaround. Yes. So it wasn't wrong, it's just that we're gonna have to do the workaround. So let's see if we can figure out what the workaround is. So we're gonna use this as a word bank to put blanks in here. So if we're going to do the confidence interval, we're not gonna have sigma, we just don't have that. But we can use something else. So let's go ahead and do another thing, pair share, and fill in these 3 blanks. The 3 blanks come from the box at the top. What was it?
So sigma is
What's
I think that's another thing that's confusing.
another way to practice?
yeah, what he's trying to do actually.
Sigma should go in the second box.
Like, it's not.
Oh, yes.
Like, I'm gonna do
So this one's population. This one here is population standard.
Sample standard deviations that come from a high, like sample size are accurate. Could be like something else.
we're winging it. I think that sigma has to use that. But you
Okay,
can't, can you even use that?
Let's share. This is the thing that's missing that we need to approximate. What is used to approximate the population standard deviation? And what is the symbol for sample standard?
Little s.
Little s. So that means, what should I be putting here at the top? Instead of sigma, I'm gonna put in my sample standard deviation. What was that? 14.89. And then my square root of n is 36. So I saw some students doing that. That's good. Sample standard deviations that come from a high blank are most accurate. And bigger sample sizes are better. You don't want a small sample because that's going to just give you luck of the draw. Okay, we'll talk more about this next class. I haven't assigned the homework yet. I'm going to try to do it by 2 o'clock today. I didn't know how hard we could get. Okay, we will see everyone next class unless you want to look over your quiz. There's actually, I hate to say this, I think there's 2 students right now that do not have the correct answer. What? Give them redemption. Maybe we'll do it. I can't say who the other person is. You can take a look at it and look over it if you want. But I can't reveal the name of the person. This person did not put their name on it. Someone didn't put their name on it. Alina, I can give you your name.
Do we get it back or do we just look at it?
You can get it right now. You can edit it if you want. That's totally fine. Who else wants to edit it besides Alina?
I don't want to edit it.
You just want to look.
Yeah, I was gonna check it.
You wanted to edit it, Rachel?
Did you like screw it or like?
No, I'm just saying I went through them and it looks like there's 2 students right now that do not have the answer. You want to take a look at it and edit it. That's all.
Are you gonna, wait, can you tell me if it's wrong?
I can't tell you. Here, Alina.
I would double check this like a million
Then
times
if
if it's
you
wrong.
feel
but-
comfortable about it,
Yeah.
just turn it in.
Okay, oh, I don't, okay,
You feel very comfortable about it?
yeah.
Well, you got the same thing. Yeah.
I got it right or wrong?
I can't guarantee anything, yeah.
Okay, well, basically,
There's a lot of extra credit at stake here. I can just give you guys all of
oh yeah, probably not. Yeah, I wanted to ask you just about my test. So
Oh, did you get it back?
I did hand it.
Okay, good, yeah.
but I was wondering if there's any sort of corrections that I could do, or if there's how much you need in person, like go over it.
Yeah, we can definitely, do you want to do it like a video chat or do you want to do like an in-person?
This is easiest for you.
Okay, we can try,
If I'm not,
are you?
I'm worried about.
Usually, yeah.
Yeah, and I'm not, and I feel like I'm not being like tested on the
Are
staff
you coming
part.
towards the end of the session?
Right now is
Our session. But on the other hand, there's a lot of extra improvement. Did you get the chance to look at that little grade where you
Hold
can
everywhere, like, we'll exceed eventually, like, the points. of the
Okay.
mark.
So,
So like.
I'll show you. If you take a look at this.
Might be like 70.
Oh, is it the thing where you take like half of the improvement
Mhm,
points and add it?
yes.
to-
Yeah, so like,
How do we
let's
get
say,
improvement points?
so let's say your first test, let's say is like, let's just look at bad test scores. And let's say your second test is an 80, you get half of the improvement
So like
with
15.
15 added on to the.
So the 50 would only be 65.
Exactly. And then this little thing right here tells you like, let's say you get a 50, or wait, no, let's say. So this thing right here tells you like how, if you, let's say you do get a 50 on the first test, but then you get like 90s on the second 2 tests, you'd end up with an 89 in the class.
There's also interesting ones like
Exactly, the improvement points. Exactly. Okay, you're welcome. You can still come to the videos chat if you want.
Yeah, I subtract.
Okay, you know, I do want to.
Okay.
I did.
Yeah.
Okay.
Okay. So much.
Everyone is like getting this except one person's a couple of people's answers were just slightly different. I
Can
don't know.
you, like, I won't touch the quiz anymore, can you tell me, like,
Yours was right.
yeah, okay, that's what it was.
But there's like a couple of people that is just slightly different. I don't know what it was that they did. It'll probably be like a compromise on the extra credit. But at least you fixed it, so that's good. You're welcome. See you next class.